Hello everyone, welcome to another video tutorial of the FEMM software. So in the previous video, we generated the model and we ran the simulation using MATLAB. I figured out the error that we had in this line. The first parameter is frequency. If I show you here, mi prob def, the first parameter is the frequency. So when we set the frequency equal to 50, actually it the frequency solver. So we want to do magneto-static simulation, so we should set the frequency equal to 0. If I run the code, as you can see here, we generate the model and we analyze it. So now I want to change the value of air gap and do a sequence of simulations. How can I do that? The first method is this one. This is the gap variable. I can write a for loop here. I can cut these two lines here after the definition of the gap. And I can write for gap equal to, for example, 1 to 10, 10 points, 1, 2, 3, and so on. Do the simulation, analyze load solution, and end. We can save these desired results, and then we can close the FEMM software. Close FEMM. So if I run the simulation, as you can see here, we can do the simulations, generate the result, and finally close the FEMM software. So the simulation was fast. Just I want to right here pause 1 second so you can follow the process, right? So as you can see here, we increase the gap and do the simulation. We can export results that we want, like flux linkage and so on. But is this a good way or no? Yes, we generate the model from scratch. Doesn't seem a good method, right? So in the software, instead of doing this, we can use another method. I can write here gap equal to 1 and generate the model, but when we generate the model, we can set the group index. I explain. And comment this line, generate the model. We can assign an index and group objects. If I click on this point, a space, as you can see here, we can assign the group index. Yes, in group. And then we can select group and move components. This is better because we don't generate the model from scratch. So here we have a function set segment prop or set block prop or set node prop, right? Properties name and group number. So here, when we generate the iron bar, define closed polygon, we can also set the group index for these points. So I can write here for I equal to 1 to 4 and mi select node. We should write x and y coordinate, I and 1, y coordinate, I and 2, pi and 2. So we select these nodes and then mi set node prop. Right here known for the first, and I assign a desired index. So I write 1 and finally mi clear selected. So let's try the code. Run. You can see here the group is 1, right? The group index. And also we should set the group index of this label anyway. You know, if I select this one, the pure iron that we have, select properties. No, this property is number of turns. The previous one is group number. Set it equal to 1. So save and run the simulation again. Run. So, you know, now we can select all objects that their group index is equal to 1. You know, if I write here mi select group index is equal to 1, we can select them. Then I can write mi move translate 5 and 0. Translate them in the direction of x-axis, right? I translated them. If I write again 5, so you can see we can move these objects. So yes, you know, this is this function. Actually, we select all of these objects, edit, move 5, yes. So we select objects and then we move them. Also, I think we should set mi set edit mode. Edit mode, we can set edit mode is group. Edit mode is group. Then we select group. Then we shift, right? And also group select shift -5. No. Let's select segments also. We should set the node properties of segments here when we generate these segments. I don't think if we select these nodes and move them all to 5. Also, we have a shift in segments, right? So anyway, when we select the group, we can shift them. So I write here move translate to check this function. dx dy 0 1 4 is group. So let's test set edit mode, select this is group. This variable. So why we cannot set this variable? Copy, move, translate. So we have this function, move, translate, magnetic input, move, translate, x and y, right? So I write here 1 and 0. So select group and let's close. The value of 8 gap is equal to 1. Then I want to shift it by 10. Cut, paste, run. Yes. And if we write -10, evaluate, set edit mode is wrong. I closed the file. Run. Then -10, evaluate. Yes. This method is better. After creation of the model, we can write a for loop here. For, I write here gap shift equal to 1 to 10, or yes, gap shift. We want to shift the gap by 1 millimeter, 1 millimeter steps, 10 millimeters, and end. Yes. Set edit mode, select group, and shift by 1 millimeter. Analyze load solution. So let's place a breakpoint here and generate the model. So you can see the model and run the simulation again. As you can see here, we shift gap, we increase the value of gap, and we run the simulation. So this method is better. We don't need to create the model from scratch. Even you can consider shift in Y, right? Suppose you want to do a linear motor simulation. In the case of rotating machines, you can rotate all inner parts of the motor. So if I run this code, run, as you can see here, we shift both in X direction and in Y direction. So we can generate the data, then create the lumped parameter model of the structure and analyze it. So, 0. How we can create animations of the generated results? We should use the post-processing options that we have. From here, magnetic output post-processor, we can do line integral, block integral, and export the output variables. Also, we can make plot type, number of points, and so on. Get integral, set edit mode, number of contours, zoom, show mesh, hide mesh, and we should have an option, I think, to save. Reload save bitmap of the result. Save bitmap. File name. I create a new folder here and I write frames. So after generational solution, can save bitmap. What is the directory? Like previous one, current directory plus frames, and then we can assign frame 1, 2, 3, and so on. So right here, index equal to 0 and index plus 1. Then we have char current directory plus frames and frame plus num to str index. So we should replace str replace 1 backslash by 2. Anyway, let's test. If index is equal to 1, this is the directory, frame 0, frame 1, 2, and output type is BMP, bitmap, save bitmap, right? So let's test, save meta file, and so on. So this is the way that we save BMP. So plus dot BMP, all frames, right? Frame, this one. So let's place a breakpoint here, generate the model. This is the model, generate mesh, run. This is the post-processing unit. Let's plot the flux density. And now if I run the code, yes, we run the model, generate, and we can save all of these frames. Later we can create the animation of our simulation. So let's go to the frames folder and open show in Explorer. Okay, you can see frames. Frame 1, 2, 3. Yes. So you can generate the animation of the simulation. So this is the method that we can generate the structure easily. You can increase the number of steps, and also you can see other post-processing functions, right? And use them. What quantities you are looking for? You are looking for flux density distributions, block integrals, or you can see these post processings here, right? Operation contours, plot xy, circuit, coil 1. You can see the value of flux linkage. Yes, you can plot the flux linkage as a function of the gap. So get circuit properties. This is the function. Circuit name, and we have current, volt, and this flux, right? These properties are returned. So if I write here mo get circuit properties, what was our circuit name? Coil 1. These are numbers. So I can write here y outputs, y3, is the flux linkage. Yes, 3.64 is the flux linkage. So, you can write you can allocate the memory for this variable, flux linkage, I write. Then flux linkage index equal to MO get circuit properties, a temporary variable can write here, and this is TMP3. So let's run simulation, analyze, we generate the flux linkage, export, and now if I plot this variable, plot, that is correct. When we increase the value of air gap, flux linkage decreases, right? So anyway, this is the method that you can do parametric simulations. We tried two methods. In the first method, we create designs from scratch. That is not good. In the second method, we assign group index to moving objects and then select them, move them, repeat the simulation, and export the desired results. So a good software, right? For 2D simulations, a good link with MATLAB for magneto-static simulations, and we can generate the model, lumped parameter model of electric motors. So in future, we will discuss how we can simulate electric motors using this software and create the finite element models. So thanks for watching.